Welcome back, Design Junkies, to Mechanical Engineering Made Simple. Okay, let's just dive right in. Take a look at this thing. What we're looking at here is a high-power electrical switching device. I mean, it's a beautiful, complex piece of machinery, right? So the big question is, how does something this intricate go from just a spark of an idea to a real, functioning piece of hardware? Well, in this explainer, we're going to open up the Mechanical Designer's Toolkit and show you exactly how it's done. And believe it or not, the very first tool isn't a tool at all. It's all about getting into the right mindset. Before a great designer even thinks about sketching or firing up the computer, they start with a core philosophy. And this quote from our source material just nails it. If you start out by making cost your number one goal, you're probably going to fail because you've forgotten the most important thing: function. First and foremost, the thing has to work. Yeah, that's the bottom line, isn't it? Make it work, make it safe. Then you can worry about making it cheaper. Okay, so with that crucial idea locked in, we can get to the real foundations of design. We're talking about the science of forces and motion. All right, so we've got the mindset down. What's the first real tool we pull out of the box? Well, it's the science of mechanics. And I'm not kidding, this is the bedrock. It's the foundation for absolutely everything we're going to talk about today. You can think of mechanics as the language of how things move, how they bend, and, how they break. It's really split into two major fields. You've got statics and you've got dynamics. And the question you have to ask is pretty simple. Is the thing you're designing supposed to stay perfectly still like a bridge? Or is it supposed to be in motion like a car engine? That answer tells you if you're in the world of statics or dynamics. And as you can probably tell from a quick glance here, the math, especially for statics, can look pretty darn intimidating. But here's the thing. All that crazy-looking math, it's really there to answer super practical, everyday questions. Like this one. Say you need a shelf to hold a really heavy box. How thick does that piece of wood need to be so it doesn't just snap in half? That right there is a classic statics problem. And the great thing is, engineers don't have to reinvent the wheel every time. They use these pre-calculated formulas and diagrams to solve it super fast. You can plug in a known force and predict exactly how that beam is going to bend, so you know for sure that your design is solid. Okay, so we've got the science covered. Now let's get our hands dirty and look at the actual building blocks. It's time to open up the designer's parts bin. I mean, look at these. The lever, the inclined plane, the wheel and axle. These are the simple machines that people have known about for centuries, and they are still the absolute foundation for almost every complex mechanism you can think of. It's kind of like a giant Lego set for engineers, right? Designers take these basic elements, springs, levers, gears, all the nuts and bolts, and they combine them to create specific motions and functions. It's exactly what's happening inside that pneumatic cylinder, and of course, inside that complex switch we started with. And let's not forget another crucial component, the cam. Cams are these amazing little parts that are absolute wizards at turning simple rotary motion into some really precise repeating action. Think about the timing in your car's engine. Yep, that's often a cam at work. Seriously, cams are the unsung heroes in countless automated machines. But here's the catch. Knowing which parts to use is only half the battle. You could have the most brilliant design in the world, but it's totally useless if you can't actually build it. And that brings us to the art of manufacturing. And this is a lesson every designer learns, sometimes the hard way. You can create the most elegant, most perfect design on paper, but if the folks on the factory floor can't actually make it, well, it's not a design. It's just a pretty picture. So the big takeaway here is that every design choice you make is tied to the realities of how things get made. For every single part, even something as simple as a spring, there's a whole design process that has to consider not just what it does, but how you're going to manufacture it. And hey, even when you finally get that prototype built, you're not done yet, not by a long shot. Now comes the fun part. You have to test it. You have to stress it, push it to its absolute limits, and prove that it's tough enough for the real world. Exactly. That's what all that rigorous testing against industry standards is for. It's the final proof that your design doesn't just work. It's safe, it's reliable, and it's ready to go. So now let's zoom out a bit and see how this all fits into the modern design process. Okay, so how does this all come together today, in the modern era? Well, as you can see, we've come a long, long way from the old drawing board. We now have this incredible digital toolkit, CAD, CAE, CAM, that lets us design, simulate, and manufacture things with a level of precision that's just mind-boggling. Think about it. These digital tools let designers test their ideas virtually before a single piece of metal ever gets cut. And that kind of integration is absolutely crucial, because these days, very few products are purely mechanical anymore. It's all about electromechanical design, blending different engineering fields together. And this brings us to a really fascinating point about what it means to be a designer today. The lines between all these different engineering disciplines, they're getting blurrier and blurrier. Yeah, the author of our source material makes this incredible argument that what industry really needs right now isn't more specialists who only know one thing. It's more general practitioners, designers who can speak the language of multiple fields and see the entire big picture. So that kind of leaves us with a final thought to chew on, doesn't it? And that's really the challenge for you, the modern design junkie. It's not just about building a toolkit that's deep in one specialty, but one that's broad enough to connect all the dots.